Okay, so today's lesson is chapter 4.7, Financial Models. And what we've been learning about the past few chapters has been exponential and logarithmic expressions. Now, those things actually have a lot to do with banking, loans, interest, investments, savings accounts, and such. So in this chapter, what we're going to be doing is we're going to be using what we've learned about exponential and logarithmic expressions. We're going to apply those to solve problems such as financial models that have a lot to do with real-world applications, as many as you've probably already gotten to experience. So before we get started, let's go ahead and start with the most basic definition that we're going to be working with today, which is the word interest. You're going to see interest a lot on the problems that we are going to be doing. Some of you might already know what interest means. That's great. But if you don't, I've included the textbook definition of what interest is. My personal definition, interest is pretty much money that you have to pay for borrowing money. So money that you have to pay for the use of borrowed money. Now, this definition directly is dealing with, like, let's say you take out a loan, they're going to charge you interest. Well, you're going to have, basically, if they say, hey, we're going to lend you $1,000. You don't only have to pay back the $1,000, you also have to pay some extra money called interest for the $1,000 that they're lending you. Now, interest doesn't only have to do with loans. It could also be savings accounts. Sometimes banks will pay you interest instead of the other way around because you're going to lend them your money for them to store. But there's so many different situations that interest can be applied to. Now, anytime you do want to calculate the interest of a certain model, we can use this formula, simple interest. Whenever you hear simple interest, that just means that they're just asking for the interest, nothing else. And that is equal to PRT. Now, these letters, there's going to be a lot of letters. These letters each mean something. So I want to write out what each of these variables mean. The capital P always stands for the principal amount. That pretty much means what's your starting amount. Principal or starting amount. So, for example, let's say you take out a loan for $1,000. Well, that's going to be the principal amount. So your principal would be $1,000. Like, what are you starting the loan out with, or what are you starting out your savings account with, etc. This R, this lowercase r, stands for the interest rate. That is how much interest they're going to be charging you. It's generally given to you as a percentage, which you'll have to convert to a regular number, which we'll get to. Okay. And then the last variable here is T. T represents the time, and it's always in years that you're going to be taking out a loan for, or you're going to be leaving money in a bank account for, etc. Time in years that this financial model is happening, pretty much. Okay. So that's what interest means. Now, another word you might have heard if you deal a lot with financials is compounded interest. Now, the formal definition of compound interest I've given to you, this is from the textbook. But my personal definition is compounded interest is pretty much, I like to think of it as interest on interest. So, for example, let's say you take out a loan for $1,000. And after, I don't know, maybe a year, they're going to charge you 10% interest. So the balance that you now owe is $1,100. Let's say you don't pay that. Well, they're going to charge you another 10% the next time they calculate that. They're not going to just charge 10% on the $1,000. They're going to charge 10% on the $1,100. So pretty much they're going to be charging you interest on the interest that you already owe. So that's why I call it interest on interest. It's pretty, or it could be a good thing. Almost all investments and savings accounts are generally compounded interest, which means when you put money into an account and it gains some interest, so it means the bank pays you, some money just for holding their money, it accrues interest. And the next time they give you another interest payment, they're going to calculate it based off of the money you put in, the principal, and the interest that it accrued. Just pretty much means interest on interest. Interest calculated based on interest you've already made or you've already been charged, depending on what situation you're in. Almost all models in the real world and also on the problems today are compounded interest problems. So anytime you want to figure out what is the amount that you're going to have to pay on something that's given compound interest, we can always use this formula. This formula is pretty important. This formula can pretty much help us calculate how much money are we going to owe on a loan, or how much money will we have in a savings account after these variables have been accounted for. Now there's a couple of different variables. Some of them we've already talked about what they mean. P is still the principal or starting amount. So that's, let's say you open up a savings account, that the principal would be how much are you going to open the savings account with. Or if you take out a loan, how much are you taking out the original loan for would be your principal amount. 1, that's just a constant, plus R, we already said what R represents, that's the interest rate. What interest rate are they going to be charging you for? N, now we haven't specified what N means, so I'm going to write that out to the side, and I encourage you to do so. This lowercase n represents how many times, it's the number of times that the interest rate is compounded. In a year. Now what does that mean? Well, that means, so for example, let's say you take out a loan for $1,000 and they say we're going to charge you 2% interest. And let's say they want to compound it yearly. Well, that means that they're going to calculate the interest that you owe once a year. Let's say they said, hey, we're going to, the end value would be, let's see. Let's say they say they're going to charge you 10% interest compounded monthly. Well, then that means that every month of the year, they're going to calculate how much interest you now owe on a particular loan or stuff. So compound is pretty much how often they're going to be calculating the interest that you owe, or if it's a savings, how much interest they owe you, etc. So N is pretty important, and it's important to pay attention to keywords like monthly, yearly, bi-monthly, weekly, etc. And we'll do some examples on that. And then the last variable we've already specified, that's the letter T. T just means how many times in years is this financial model going on. Okay. So make sure you have these 4 variables written down, what they each mean, and we'll do some examples to kind of do some more practice with this. All right, example number 1. Let's just do a basic example on how to compute compound interest. So let's say that a credit union is going to pay 2% per annum, that just means a year, 2% a year, compounded quarterly on a certain savings plan. If $1,000 is deposited in such a plan and the interest is left to accumulate, how much money is in the account after 1 year? Now that's a lot of information, but the first thing that we want to do is figure out what are they asking. They're asking how much money is going to be in the account after 1 year. So what we're trying to figure out is what is the ending amount of money after a certain period of time, or after 1 year. And that is what this formula up on top is so useful for. This capital A, I don't think I specified, that is the ending amount. So I'll go ahead and write that. Ending amount of money in the account after, all these variables have been taken into account. So we do want to find what's the ending amount, what's the amount after 1 year. So we are looking for A. And I'm just going to rewrite this formula down here. P1 plus R divided by N to the NT power. Okay. So the goal is to figure out what A is. Well, all I have to do to figure out what A is figure out what are each of these variables and kind of plug those in. So let's go ahead and start doing that. Let's go ahead and start with P. P is the principal amount. So now we're dealing with a savings plan. So you're going to be putting in money into some sort of savings plan. If we read back through the problem, can we find what is our starting amount? How much money are we going to originally deposit into this account? Well, if you look right here, we said that $1,000 is deposited into the account. So that would be my principal amount. So my P value is $1,000. Okay. All right. 1 is just a constant, plus R is the interest rate. That's how much interest they're going to be paying you for the savings plan that you're going to be opening with them. Now, if you're not sure what, where it is out of all the numbers, it's generally always a percentage, and really there's only one percentage, and that's 2%. Now, many people would put, oh, well then the R value is 2 because it's 2%. Not necessarily. Our R value, our interest rate, is 2%. Now, 2% as a regular number is not the number 2. 2%, and the way we convert from percentages to a regular number, is we just take the decimal, which is right now after the 2, and we move it over 2 spots to the left. You basically make some butt cheeks, and that'll be your new decimal. So our 2% is 0.02 as a regular number. Okay, that is very important, because if you plug in the number 2 for R, you will get a completely different number and it will be inaccurate. So going back to our formula, my R value is 0.02 divided by N. Now, N is the number of times that they're going to compound the interest in a year. Now, it does say that it's going to be compounded quarterly. That's how often they're going to be computing basically the interest on interest. How often are they going to recalculate what interest they owe me on this savings? Well, it says they're going to compound it quarterly. Now, quarterly, think of quarters, there's 4 of them. It happens 4 times in a year. So our N value is 4. And the reason why I knew that is because it said quarterly. It's really important to know the vocabulary. Quarterly means 4 times a year. Annually means once a year. Monthly, 12 times a year. Weekly, well, how many weeks are in a year? 52. So it's really important to pay attention to these keywords. In this case, it's quarterly. And that means it's going to happen 4 times a year. Okay. So going back to my problem, N is 4, so I'm going to divide it by 4. And then it says raise it to the N, which we just said was 4, times T. Now, T is how many times or how many years. What is the time in years? And if you look, it says we want to keep the money in the account after 1 year. So that would be the time in years that we're going to have money in the savings account. So our T value is just 1 year. And that's what I'm going to plug in for T, 1. Okay. And then once you have all of that, notice all of these are just numbers. They're all things I can type in the calculator and help me calculate. So I'm going to do just that. I'm going to go ahead and go to my calculator. I'm going to type in 1,000 times 1 plus, and I like to use a fraction template, alpha y equals, enter, 0.02 divided by 4. Make sure the parentheses is closing that whole thing up. You're going to raise it to the 4 times 1 power. Make sure the 4 and the 1 are both in the exponent section. Enter. And I got 1,020, and I'm rounding, so I'm going to go ahead and put 1,020 and about 15 cents, because the third decimal is 0, so it doesn't round up. And there's our answer. Now, what does this mean? That means if you go to a bank and you say, I want to open up a savings account, you give them $1,000 and they say, okay, we're going to pay you 2%, we're going to compound your interest quarterly, and you leave it in there for 1 year. Well, if you look back at that account, in 1 year, you'll now have $1,020.15 rather than just $1,000. You've basically made interest, you've made money just from giving the bank your money to hold. So that's that is what interest means, and that is why this formula is so important and it's so useful, especially if you plan on working at a bank or are already working at a bank as a banker or an accountant, anything financials. These type of formulas are so important, and you'll see them occur in those types of jobs. All right, let's move on to another. Okay. All right, we're going to do another example. I'm going to try to go over it a little bit more slower than this one, just in case anyone didn't catch on to that one. So, very similar problem, just some different values and numbers. I'm going to go ahead and leave the formula up at the top so I don't have to keep scrolling back. Okay, example number 2. Let's say that you want to make an investment and you're going to invest $1,000 at an annual interest rate of 10%. Calculate how much money is going to be in the account after 1 year, if the rate is compounded annually, semi-annually, quarterly, monthly, and daily. So there's actually going to be a couple different answers. We have to figure out an answer if the interest rate is compounded annually. Then we have to figure out an answer if the interest rate is compounded semi-annually, and so forth. But let's go ahead and just start with the first problem, which says if the interest rate is compounded annually. So the goal of the problem is to figure out how much is going to be in the account after 1 year. Now, first off, we're trying to figure out the ending amount, which is A. So the goal of this is to figure out what is the A value. I'm going to write this formula again so I can kind of scroll up. P times 1 plus R over N to the NT power. Okay. Now I'm going to figure out what are each of these values. If I'm opening up an investment account, what is my principal amount? That means how much am I going to open up the account with? Well, it says you're going to invest $1,000, so we know that our P value is $1,000. So I'm going to go ahead and start writing my first answer, which is A equals P, which is $1,000, times 1 plus R. R is the interest rate. That's how much interest they're going to pay you of the $1,000. So they're going to pay you 10% interest, which is really good. So my interest rate is 10%. Now 10% though is not my R value. Remember, we have to convert that to a regular number. So 10% as a regular number, you just take the decimal, you move it 2 spots to the left, and the new number, or the number that we're going to use as R, is 0.10, or just 0.1. Either way is fine. And that'll be our R value. So when I go back to my formula and I have to plug in an R value, I'm going to plug in 0.10. Okay. The next value is N. Now N is how many times a year that this is going to be compounded, which means how often in the year are they going to be recalculating the interest that they owe you. Okay. Now it does say that it's going to be compounded annually, semi-annually, quarterly, monthly, and daily. So there's a couple of different answers we're going to have to get. We're going to have to do each time for each of those. But let's go ahead and start with the first one. Compounded annually means our N value will be 1. Semi-annually, that means twice a year. So in that case, our N value will be 2 when we do calculate the semi-annually. I know we're not doing them all together, but I'm just going to write them down. Quarterly means that means that it's going to happen 4 times in a year. They're going to calculate the interest that they owe you 4 times in a year. Monthly, that means that the N value will be 12, because that means that they're going to calculate the interest they owe you 12 times in a year. And daily, well, if it happens daily, how many times will that happen in a single year? Well, there's 365 days in a year. That means our N value will be 365. So we're going to have 5 different answers for this problem, and I just wanted to write what each of those N values will be. Now, you might be wondering, why do they have to recalculate interest twice a year, 4 times a year, 12 times a year? Why can't they just calculate the interest once? 10% of 1,000 is 100, and just continue to give that. Well, remember, compound interest is interest on interest. So, for example, let's say that you got $1,000. They're going to give you 10% of that, which would be $100. So you would then have $1,100. Okay. Well, let's say they're doing it monthly. Well, they're not just going to give you $100 for the year, because that's annually. Let's say they're going to compound it monthly. That's an even better one. That means they're going to give you 10% every month. So for the next month, $1,100 will now be given a 10%, which is, well, I don't know, times 1.10 every single month. And if you notice, they're now calculating interest on the $100 that you made, on the interest. That's why it is called interest on interest. These might not be the most in-depth definitions. I know the way I'm explaining it, so I really encourage you to feel free to take on your own research and to what does compound interest actually mean, and get a bigger grasp of it if you need to, if this is all new to you. Okay, but pretty much compound interest is interest on interest. You're making money off of the money that they've already given you, which is really nice. Okay, but for our first problem, I'm just worried about annually, so I'm going to go ahead and just finish doing this problem. So if we're doing annually, my n value will be 1. I'm going to raise it to the n, which again is 1, times t. T is the time in years that you're going to have this money in your investment. And it says our time will be 1 year. So my t value is also 1. And then I'm going to calculate that. I'm going to just use my calculator to help me find all these calculations. $1,000 times 1 plus 0.10 divided by 1, close the parentheses. I'm going to raise it to the 1 times 1 power. Make sure that all the 1 and times 1 is both in the exponent area. And I got $1,100. This is how much is going to be in the account after 1 year of your investment. If you don't add any money or if you don't take out any money, that's how much will be in the account after 1 year. So you'll make $100 just by having your money in the account sitting there. Now let's say the same problem applied, but we wanted to calculate how much is going to be in the account after 1 year if the interest rate is compounded semi-annually. Semi-annually means twice a year. So I'll go ahead and do the same thing. I'm going to set up the same problem. My principal amount hasn't changed. It's still $1,000 times 1 plus my interest rate hasn't changed. It's still 10% or 0.10 as a regular number. The n value is how many times it's compounded in a year. And if we're figuring out for semi-annually, write that off the side. Semi-annually, that means it's going to happen twice a year. So our n value will be 2. And I'm going to raise it to the n, which again I said was 2, times t is the time in years, which it just says 1 year for all of these problems. And I'm going to calculate that. Actually, I'm just going to copy and paste. I don't have to retype that thing in. Just all I have to do is go back and change this denominator to a 2 and the exponent to 2. You can retype it if you want. I was trying to save myself some time, so I used that copy and paste feature. Alright, and that's how much will be in the account. $1,102.50. So a little bit more, basically an extra $2.50 if it's compounded semi-annually versus if it's compounded annually. Okay. Alright, next one, we're going to see how much will be in the account if they're going to tell you that they're going to compound the interest rate quarterly. So same formula. The principal amount is still $1,000. 1 plus R, the interest rate is still 10%. And our n value is now going to be 4 because we're figuring out for quarterly. That means it's going to happen 4 times in a year. I'm going to raise it to the n, which is 4, times t. T is the time in years, which is still 1. I'm going to type this in now. I'm going to just copy and paste, change those 2's to a 4. And I got $1,103, so $1,103 and about 81 cents because I know I'm rounding. Okay. So you can see the more times that they compound the interest, the more money that you're going to have, which is really nice. Alright, next is monthly. Let's say they're going to offer you this plan, except they're going to compound the interest monthly, meaning 12 times a year. My principal will still be $1,000. 1 plus my interest rate will still be 10%. The n, that's the only thing that's going to change, is monthly. Monthly means 12 times in a year. I'm going to raise it to the n, which again is 12, times t. T is still 1 year. Let's see what we get here. Let's go ahead and retype that. Change those 4's to a 12. $1,104. Now some of you might be thinking, okay, yes, it's increasing, but it's not by that much. I mean, this one was $1,100. This one's only $1,104. So it's only a $4 difference. And that might be true, but we're only dealing with $1,000. Imagine if we were dealing in the millions or multi-million and billions amounts. Those small differences would be much more than $4, and it'd be much more of a significant difference in those cases. But when you have something a little smaller, like $1,000, the differences might not seem like they matter that much. You're only going to make a few more bucks doing it monthly versus annually. But again, this is a small scale example. Okay. And then lastly, it says also figure out how much will be in the account if they compound the interest daily. So my last answer will be the principal amount is still $1,000. Our interest rate is still 10% or 0.10. Our end value, if it's daily, the interest compounded daily, is 365. To the n, which we just said was 365, times t. T is the time in years, which I never wrote, but let me go ahead and write that. Times 1 power, which is equal to, let's go ahead and type that in. And I got $1,105. And about 16 cents if I'm rounding up the third decimal. There you go. So these will be the amounts in the account in these 5 different scenarios, depending on how often they're going to compound the interest. So the more often that they compound interest, it's pretty good if you're talking about savings and investments. That means they're going to pay you more money the more that they compound. This might compounding interest more often might not be a good thing if you're talking about loans and credit cards and things you have to pay back, because that means, well, they're going to charge you more money the more often that they compound your interest. So it just depends what situation you're in. All right, moving on. So anytime you see compound interest formulas, you definitely want to refer to this formula to help you find those answers. Okay. All right, moving on. So the next type of problems that we're going to do is compound interest problems, but this one is called continuous compound interest. Okay. Now this one is very common, and it's actually a good kind of interest if you're talking about savings and investments. Like I said before, our end value can be different things depending on how often they want to compound the interest: daily, annually, semi-annually, quarterly, etc. There is another type of compound interest, and it's called continuous compound interest. And what this means, and here's the formal definition, it means that they're going to compound the interest, meaning they're going to keep on calculating the interest on the interest already, but they're going to continuously do so. Okay, they're not going to just do it once a year annually. They're not just going to do it twice a year semi-annually. They're going to do it continuously, meaning any change in the amount, they're going to constantly compound the interest on. So this is a pretty good type of account to have if you're talking about savings or investments. Not so much if you're talking about loans and credit cards. Continuously compound is pretty much their way of saying they're going to charge you the most money the most often that they can. So it just depends again on what type of situation. Now, the key word is, when you read problems and homework problems, the key word is anytime you see the word continuous compound or continuously compound, it is very important that you follow this formula's model. It is different than the one I told you guys earlier. Let me refer to it. It is different than this one. This one is just compounded interest based on, different however many times a year. Anytime you see continuously compound, you won't see quarterly, bi-weekly, you won't see any of those vocabularies. Continuously compound just means you'll follow this model. Okay, so keyword continuous. You'll use this model. Okay, so that's just the important part to know which formula we'll use. We'll use this one to calculate how much money you're going to have in an account, or this one. And the best thing I can tell you is anytime you see the word continuous, automatically that tells you you're going to be using this formula here. Okay. All right, so let's do an example, but before I do that, let me go ahead and say what each of these variables mean. We already know what P means. Remember, P is just the principal amount. I'll write that again. That's how much you're starting with. Okay. R is the interest rate. It's always generally given as a percentage. T, the little lowercase t, I don't know if you can see that, but that says RT, is the time in years that this investment or loan or whatever is going to be going on. And this E, for those of you that don't know what E is a famous irrational number, very similar to pi. It is about 2.71, and it has some other numbers associated with it. You won't ever have to plug in a number for E. E is an actual number, and your calculator does have it. I know mine is, I have to push second and then this LN button, and it gives me E. And it is 2.71, and actually the decimals go on forever. It's irrational. There's still calculating more and more decimals to this number as we speak. But it is just a rational number, and we'll be using our calculator to help us calculate that number instead of having to worry about it by hand. Okay. All right, so like example 3, we're going to do an example with continuous compound. It says calculate the amount A, so the ending amount in an account, that results from investing a principal amount of $1,000 at an annual rate of 10% compounded continuously for a time of 1 year. Now the key word, like I said, anytime you see compounded continuously, that word is so important. You're automatically going to be using this model right here. I'm going to go ahead and write it in case it's not that large for you to see. P times E to the RT power. And all I have to do is figure out what A is. Well, in order to figure out A, I just have to figure out what each of these values are. So let's go ahead and start with P. P is the principal amount, which it even tells you is $1,000. So that's the number I'm going to plug in for P. E, I don't have to plug in a number. E is a number. It's 2.71. I'm just going to write it for now. Raise it to the R. R is the interest rate, which is 10%. As a regular number, though, remember we take the decimal and we move it 2 spots to the left, which is 0.10. So I'm going to raise it to the 0.10 power times T. T is how much time in years that this investment's going to go on, and it says 1 year. So my T value is 1. And then I'm going to go ahead and calculate that. This is very similar to the previous problem, except same $1,000, same 10%, except instead of compounding it annually, semi-annually, quarterly, it's just going to be compounded continuously. So let's see which one is better. Let me go ahead and type this in. 1,000 times E, raise it to the 0.10 times 1 power. Make sure that 0.10 and 1 are both in the exponent. And I got $1,105 and about 17 cents. And that's how much money will be in your account, your investment account, after a year if it follows this model. So if you compare it to the problems up on top, this one is actually the best one I have. 17 cents. I know it's only 1 cent more than if we did it daily. But again, we're looking at small scales. These numbers might make a much more big of a difference if we're dealing with millions and billions of dollars. But this is the best type of interest to have if you're talking about investments or savings accounts. It just means they're going to give you the most money possible, the most interest on the interest you've already made from them, which is nice. Okay. All right, let's go ahead and do some more examples just like that. I'm going to go ahead and leave this formula up on top because we are going to be using that one again. Okay. All right, example number 4. How many years is it going to take for an initial investment of $10,000 to grow to $50,000, assuming that a rate of 6% is compounded continuously? Now, first thing I notice is that it says compounded continuously, so automatically I know I'm going to use the continuously compounding formula, which is this one right here. I'm not going to be using this first one, because it says continuously compound, keyword. So I'm going to go ahead and write down that formula again. A equals P times E to the RT power. Okay, I don't need that anymore. I can kind of fill it now. Now, the question is not asking us to find the ending amount. We actually know the ending amount. They want it to be $50,000. The question is, says figure out how many years. So we're actually trying to figure out T. That's what we don't know. We know everything else, but we don't know what T is. So the goal is to figure out what is T. What is T? I'll even write it down here. T is what? Remember, that's how many years it's going to take. Now, it tells us some other things. It does say that the initial investment, remember initial means the starting amount, is going to be $10,000. So that is going to be our principal amount. So our P value, that's what we're going to start the account with, is $10,000. So for the P, I'm going to plug in the number 10,000. Okay. It says that they already know what they want what amount they want to be in the account at the end. They want it to be $50,000. That's going to be the ending amount. They're asking how long is it going to take for my ending amount to be $50,000. So my A value, I'm going to plug in 50,000. Okay, I know that my ending amount is 50,000. Remember, P means the starting amount. That's the principal, what you started with. And A is the ending amount. That's what you want the account to end up with. Okay, times E. We already know E is just a number. All right, R, do I know what R is? R is the interest rate. Well, it says the rate will be 6%. Now, 6%, though, as a regular number, you take the decimal, move it 2 spots to the left, and the number is 0.06. So our R value will be 0.06. Okay. I don't know what T is. That is the time in years. We don't know how many time in years. That's what the question is asking. So we're going to just plug in the number T. Okay. Now you can't use your calculator to try to figure out T. I mean, they don't know what T is, and you can't just type in a T and hope they'll figure it out. But we can do some work with it by hand and to eventually get the answer. The goal is to figure out what is T. So our goal from here is to solve for T. Okay. And what we're going to do is we're going to start with the side that T is on. T, I'm going to separate my two sides. T is on the right hand side, so I want to get rid of everything else other than the T so that I can get T by itself. Just like when we're solving for X, we get rid of everything else but X. Same thing here. We're solving for T, so we have to get rid of all of these other terms. Now, we're going to start with anything on the outside, because T is in the exponent area, so you do want to get rid of this base E. But before you do that, let's get rid of anything outside the base. Let's get rid of this 10,000. 10,000 is being multiplied by E. So what is the opposite of multiplication? Well, it's division. So my first thing would be to divide both sides by 10,000. Kind of ran out of space here, but you get the point. 10,000 divided by 10,000 is just one whole, so those will cancel out. And I am left with, let's see, 50,000 divided by 10,000 is 5. And I'm left with an E raised to the 0.06 T power. Okay. All right. Now, I still don't know what T is. I do want to figure out what T is. Right now, T is in the exponent area. And so I do want to get rid of the 0.06. Before I can do that, I have to get rid of this base. This has a base E. Now, before we even try to get rid of a base E, this form is an exponential form, okay, because you have T's in the exponent area. So this is an exponential form. Just like what we did the last few classes, anytime you have something in exponential form, you can't really solve it in that form. It might help to convert it to logarithmic form. Okay, so that's exactly what we're going to do. We're going to convert this to log form. And the way this would be written in log form, it would be written as log base E. My base is whatever has an exponent, and the base in this case is E, of 5 equals the exponent, which the exponent is this whole 0.06t. So what I've done is I've taken this. It didn't really work in exponential form. I can't do much else, so I'm going to convert it to log form, which I've done. And that's just log base E of 5 equals 0.06t. Okay. Now, log base E, remember, you could have also written log base E as, anytime you have log base E, that's the same thing as natural log of 5. Same thing. So if you prefer to write it this way, that's also fine. It's not wrong if you want to leave it in this form, though. Okay. You have two options. You can either leave it in this form, in which case you can actually type that in using our change of base formula. So I would type it in as log of 5 divided by log of E. That's one way to write it. And get your answer if you want to figure out what that is. Or you could just use natural log of 5, because log base E of 5 is the same thing as natural log of 5. You could have also done that, and you'll get the same answer. See? But regardless, log base E of 5 or natural log of 5, however you want to notate it, is 1.60943, etc. So I'm going to go ahead and write that. 1.609. I'll just go ahead and round it to 3 decimal places for now. It's approximately 0.06 t. Okay. And then lastly, we are trying to solve for t, so the only thing I have to do now is get rid of this 0.06. And the way I'm going to do that is these two things are being multiplied, so I'm just going to divide them. Divide both sides by 0.06, 0.06, and 0.06 divided by itself will cancel out. And t is equal to 1.609, I'll just leave it typed in, divided by 0.06, and this is what I got, 26.8239. So I'm going to go ahead and write about 26.8 is our answer. Okay. Now I know this had a couple of steps, and this can be very tricky for some, especially if interest is completely new to you all. And my best advice would just be to continue to practice and practice. And again, we're going to do some a little bit more of some examples to help you get comfortable with it. But these type of problems are essential in careers such as banking and anything that has to do with credit cards and loans and accounting and all that sort of stuff. But this is a simple problem that, you know, it would be pretty useful if you have a goal to reach. Let's say I want to make sure that this 10,000 grows to, you know, 50,000 or $1 million. How long is that going to take me? And those are the types of questions that people that make money off of investments are really asking themselves. So that's a nice investment growth to basically, you know, make your money grow by 5 times. But it's going to take 26, almost 27 years for that to happen if this is the model that is given to you. Okay. All right. And you can always check that this answer is right by plugging it in for t and seeing if it gives you a true statement. Okay. All right, let's go ahead and do another example. Okay. All right, example 5. If you want to have an ending amount, so you already know what the ending amount is going to be. You want it to be $20,000. So my ending amount will probably be, well, it'll be A. So I'm going to go ahead and just call it A. After 3 years, that's how many time in years, so I know that's going to be our t value, in an account that is continuously compounded. Remember, anytime you see the keywords continuously compounded, you are going to use the continuous compound formula, which is A equals PE to the RT, APERT, is how I like to pronounce it. So I'm already going to write that formula down because I already know that's the formula I'm going to be using because it said continuously compound. If it did not say continuously compound, I would be using just a regular compound interest formula. Okay. What should your principal amount be? So in this case, we don't know what our P value is. We're trying to figure out what's P. We know everything else, we just don't know what P is. So let's go ahead and plug in some numbers. A is the ending amount. Remember, ending amount. And we already know what we want in the account ending to be. It says you want to have an ending amount of $20,000. Okay. We know that the time in T is 3 years. Okay. And so let's go ahead and plug this into our formula. We know that A, like I said, was $20,000, so I'm going to plug in A for 20,000. P, we don't know what P is. That's what it's asking for. We don't know what that is, so I'm just going to leave it as the P. E, remember, E is that number 2.71, and it continues on. I'm going to leave it as the letter E, though. Okay. R is the interest rate. Well, it didn't say interest rate here. Let me see. Okay, so actually, I think when I typed up these notes, I forgot to include the R value, but that's fine, not a big deal. I'll go ahead and just include it, and we'll just pretend it was there. I'll go ahead and add it. Assume that the rate of 5% interest. So sorry, that should have been part of the problem, and it should always give it to you. There's no way to answer this problem without it. So back to our problem. Our R value, I just said, was 5%. But as a regular number, 5% would be 0.05. So when I'm plugging in R, I'm going to plug in the number 0.05 times T. T is how many times, what are the number of years that have gone by? And that'll be 3. Okay. So I know everything except for P. So I'm going to just solve for P. So what I have is I have 20,000 equals P, which we don't know. Now e to the 0.05 times 3, I don't know what that is, but I can calculate that by typing it in. E to the 0.05 times 3 power. And I got 1.1618 approximately. So this is just 1.1618. And I'm rounding, obviously, so I can use rounding symbols instead of equal symbols. Okay. I'm almost done. I just have to get P by itself. So all I have to do to get P by itself is, well, the opposite of multiplying by 1.1618 is dividing both sides by 1.1618. Okay, those will cancel out. And our principal amount, that's how much money should have been in the account to start with to reach this goal. Now, especially on your homework problems, you don't really want to round until the end. So the way I'm going to do this is, just so I'm not rounding, 20,000 divided by, and instead of just rounding, I'm actually going to just copy and paste my last answer. So if you can do that on your calculator, great. And it kind of copies and pastes it where you want to. 20,000 divided by this whole number, so I didn't have to round until the very end, is 17,214 and about 0.159, so I'm going to round that up to 16 cents. And that's our principal amount. Now what does this mean? This means that if you want to have an ending investment amount of $20,000 after 3 years, and if it's continuously compound and they'll charge you 5%, that means that you need to start the account up with $17,214.16. You need to be able to walk in the bank and say, I have this much money, please put in the account, and be able to walk in 3 years later and know that $20,000 will be there waiting for you. Okay. All right. And that is it. Okay. All right. Another example. Example number 6. What annual interest rate, what annual rate of interest compounded annually? Now, keyword, that says compounded annually. Does not say continuously compound. So I'm not going to be using this one because that's continuous. And nowhere does it say continuous. I will actually be using just the basic compound interest formula, which is this one right here. I'm actually going to go ahead and write that down because I already know that's the one I'm going to use. Okay. So it says what annual interest rate. So I know we're already trying to figure out what R is. We don't know what R is needed to double an investment in 5 years. Now let me write down what I do know. I do know that the time in years that you want to have this investment going on is 5 years. So I know T is going to be 5. What else do I know? Do I know what N is? N is how often is it compounded? Is the interest compounded? It says it happens annually. Now annually means once a year. So our N value will be 1. Okay. We're trying to figure out R. What about A and P? A is the ending amount and P is the starting amount. It doesn't tell me actually either, but it does tell me what annual interest rate is needed to double an investment. Now the cool thing about these is, even though it doesn't tell you what A is or P is, it does tell you all it wants to happen is for you to double your investment. So you can honestly make A and P whatever numbers you want them to be. Just make them one double the other. And you'll get the same answer regardless, which is pretty cool. So if you want, you could really make up numbers. So I'll go ahead and write this. P is the starting amount and A is the ending amount. Okay. Again, it doesn't tell you this, but it does tell you that it wants you to double the investment by the end of these 5 years. So whatever your starting is, just make the ending one double. And again, you can really make it any number. If you wanted to make the starting amount $1, you could make the ending amount $2. If you wanted to make this 1,000, you could make this one 2,000. You could honestly pick whatever numbers you wanted. It really doesn't matter, just as long as the ending is double the starting. And you'll get the same answer regardless, which might not make any sense, but these two numbers are really just a ratio of the other. So no matter what numbers you plug in, as long as one is double the other, our interest rate is going to be the same. Okay? You can pick, if you want to pick the number 50 and then put 100 here, that's also fine. Again, it doesn't matter. All that matters is that we're doubling the investment. And if I started with $1, the ending amount would be $2. And that is okay. So I'll go ahead and just use 1 and 2, but you can use bigger numbers if you want. It doesn't matter. So if I'm using this model, I'm going to go ahead and plug in A is 2. Our p-value is, in our case, 1. Times 1 plus R. We don't know what R is. That's the interest rate. That's what I'm trying to figure out. R. N is the number 1. Raise it to the n, which we just said was 1. Times T. T is 5. Okay. All right, let me see what I can calculate in this case. I have 2 equals 1 times anything is just itself, so I really don't need to leave that on there. I can kind of bring it down. Let's see, I have 1 plus R divided by 1 is just R. 1 times 5. 1 times 5 is 5. I'm just simplifying some of the math. This 1 is unnecessary because anything times 1 is itself. R divided by 1 is just R, so I kind of left it off. 1 times 5 is just 5. Okay. Now this still doesn't help me. I still want to figure out what this equals. Let's see. I have 2 equals 1 plus a number R. That's what we're trying to figure out, to the 5th power. I'm trying to solve for R. So my next step is I want to get rid of everything else but R. I want to get rid of this 1 plus. I want to get rid of this 5. I'm going to start with the outside and then work my way in. I want to get rid of this 5. This is the 5th power. Okay, it's not the same as times 5. This is 1 plus R to the 5th power. Just like if it was a 2nd power, we would take the square root. But it's a 5th power. So the way that we would get rid of a 5th power is we take the 5th root of both sides. Okay, just like if this was the 2nd power, you would take the square root. That's the 2nd power. If this was the 3rd power, you would take the 3rd root. Well, just like the 5th power, you would take the 5th root and it'll cancel it out. Okay, so this 5th root and this 5 will cancel each other out. And what is the 5th root of 2? Well, I don't know what that is, but your calculator is actually able to calculate those. I know it might have a few different features, but I want to say I know on most calculators, you just have to push the math button, M-A-T-H. And if you look at the number 5, let's see if it's clear, that basically will let you plug in any number for it. And you can just push number 5. Now it does this. If your calculator looks a little different, you might have to play with it. But I'm trying to figure out what is the 5th root of 2. Okay, and that's what I got, 1.1486 approximately. So 1.149 if I'm rounding. I'm just going to round to 3 decimal places. And all I'm left with on the right-hand side is 1 plus R. Okay. I'm almost done. I'm just trying to figure out what R is. So all I have to do now is get rid of this plus 1 by subtracting 1 from both sides. And those will cancel out. And our R value is approximately 1.149, this basically this last number, subtract 1, which is 0.149 if we're rounding the 3 decimal places. And it didn't really say how many decimal places to round to. So I'm going to just round to 3 decimals. If it tells you to round to 3, you can round to 3. But it didn't tell me, so I'll just round to 3. Now that's the R value. You can leave it as a regular number. Remember, R is the interest rate. Or you can write it as a percentage. And that would basically mean take your decimal, move it 2 spots to the right, because we're going from a number to a percentage. And that would be 14.9%. Okay, I don't know which one it'll ask for, but those are the 2 ways you could write it, depending on which way it's asking for, as a percentage or as a regular number. Okay, and there we go. Okay, all right, and last example, it's very similar to the one we just did. I'll just do part A of it, and I'll leave you to do part B if you'd like to try to get more practice with it. But part A says, how long will it take an investment to double in value if it earns 5% compounded continuously? Remember, keyword, anytime you see compound continuously, you automatically know that you're going to be using the continuously compounding formula, which is A equals PE to the RT power average. So I'm going to go ahead and write that down. A equals PE to the RT power. Now, you want to figure out how long. That just means how many years. So we don't know what T is. That's the goal of this problem. So it's very similar to the last one. Trying to figure out what is our T value, how long is it going to take. If you want an investment to double, and it earns 5% compounded continuously. Now, what do we know? Let's see. We don't know what T is, but do we know R? Yes, we know that R is the interest rate, which is 5%. As a regular number, though, you would write that as 0.05. Okay, so we know what R is. E is just 2.71. P and A, it doesn't tell you what your starting and ending amount is, but it does tell you, just like the last problem, that it wants your amount to double in value. So it doesn't really matter what P and A are, as long as the ending amount is double the starting. You can honestly plug in the numbers. You can plug in $5 for starting and then $10 for the ending. You can plug in 2 and 4. It doesn't matter. I like to just be super basic, and I'll just start with 1 and 2. $1 and $2. Regardless, this is simply, these two numbers are a ratio of each other. So no matter what numbers you pick, as long as one is double the other, the ending is double the starting, then you'll get the same R value or the T value that you're solving for. Okay, that's all that matters. So I'm going to go ahead and plug in everything I know. I'm going to plug in $2 for A, $1 for P, E is just 2.71, R is 0.05, and T is, we don't know what T is. That's how long it's going to take in years, and that's what we're trying to figure out for this to happen. Okay. All right, let me see if I can solve some of this. We have 2 equals 1 times anything. Well, 1 times anything is just itself, so I don't even have to write the 1. I can kind of just leave it off. E to the 0.05 T. Now, this is similar to example 5. We're trying to solve for T, so I want to get rid of everything else. I want to get rid of the 0.05. I want to get rid of this base E. Now, right now, this is an exponential form. It's not helping us much. I can't really do anything. I can't try to divide by E because E is a base and T is in the exponent. So anytime you have something in exponential form and you can't really solve it, your next step would be, well, convert it to log form and see if it's more useful to you in that form. So the way we would convert it to log form is we would write it as log. Base is whatever has an exponent on it, which is E, of 2 equals 0.05 T. And if you're wondering, how did you do that? This is a review of the last couple of chapters we've been covering, so if you need help with converting, look at the last couple of chapters we covered. Okay, and this is just converting. It's basically another way to write the same equation. Alright, log base E of 2, you can leave it like that, or remember you can also write, anytime you see log base E of something, you could also write it as natural log of 2. Same thing. That's why I put or. Either one. Okay. I can actually calculate what that is though. You could, if you wanted to try to type in log base E of 2, you can't type it in like that, but you could use the change of base formula, which we learned about. Log of 2 divided by log of E. Delete. Or you could just do natural log of 2. Either one. You'll get the same answer. See? Either way, you get the same answer. But it's 0.6931 approximately. So 0.693, I'm just going to round. And I'm rounding, so I did approximate symbols, is about 0.05 times T. Okay. Basically, how did I get this number? I calculated it. Alright, I'm almost done. I just want to solve for T. So I just want to get rid of this 0.05 that's being multiplied by it. So the opposite of multiplication is division. So I'm going to divide both sides by 0.05. Okay. And 0.05 divided by itself, that's just 1 whole, so that cancels out. And I'm just left with T is equal to 0.693. I'm just going to leave that type in, and I'm going to divide it by 0.05, and I got 13.8629. It's kind of important to not round until the very end, so that's why I just leave it typed in and I kind of work from there. But I got 13, and it doesn't say how much to round to, but I'm going to round to my 3 decimal places like I usually do. 0.86, and it says 29, so it'll round to 3. And this is how many years it's going to take to double an investment, whether it be $1 to $2 or, I mean, it'd take 13 years to grow from $1 to $2, which is kind of a long time. But let's say you had $1 million, you want it to grow to $2 million, and it was a 5% interest rate, etc. It would still take 13.86 years for it to grow. Okay. And then part C, if you wanted to do that, you can go ahead and do that on your own. It says how long will it take to triple this rate. It's pretty much the same problem, except instead of doubling, you would want to triple. So if you wanted to start with $1 and end with $3, you could follow the same model. But I'll leave that for practice if you'd like to. And that's it.